Hi, I wanted to give you an example today of a couple of tables that I put together entirely using AI. So I used different AIs to do the research and come up with some ideas for these tables in terms of what they might show. And then I exclusively used Google Gemini, which was 2.5 Flash, which is free, to create these tables. And so the prompts to create the tables were reasonably straightforward. I asked for a one-page HTML, which used the canvas ability. So the canvas, when you click on it, just opens this right-hand column here. It will write the code out for you, and then you can click preview and you can see what's going on. All the time you can have the chat section open on the left. So yeah. So initially, in fact, I asked ChatGPT to come up with some ideas of trends in AI that would describe to you what's happening in the industry and what we can expect to see. So, like, there is this idea in tech a lot of the time that there are these bubbles, and that things are never quite as good as they first appear. I don't think this is actually true about AI, and I think largely speaking, those ideas have been around tech investments. Now, I'm not particularly interested in the investment side, and in terms of the application of AI, I think we've not even scratched the surface. We have come up with a tool that is so complex and so multifaceted that we don't really know what we're going to be using it for. So it's an interesting time because we're thinking of new stuff pretty much every day. So let's just have a quick look. I have a little bit of a background in making websites, so I'm aware of certain things. And one of the things that I asked Gemini to do is I asked it to make me a table that looked really nice, and to look at using this JavaScript library called D3JS, which I know to be open source. And if you just look at these tiles, each one of these tiles represents a graph. And you can see that this JavaScript library has the capacity to make the most incredible graphs. Okay, so looking at our graph, what I can say about it is that it's really good. It uses quite subtle colors. I asked it to do that. It's not very fancy, but it does exactly the job I wanted it to. I asked at the prompt, I asked to use a CSS framework to give consistency. You can look them up if you like, but they're not that important. You could do this without knowing any of that stuff by simply asking the question, and the AI would go out and look for an answer for you. Now, what I did ask, which is interesting and useful, is that I asked it to present the key as a table. I had to work on this a little bit with it, and I asked it to make it such that if I click on the key in the table, it will make bold the line on the graph. And it did that very nicely. So click make bold, click make bold. So we can see what we're doing here. And just then using the table itself, we can look at the global AI market size, year-on-year growth for 24-25, 1.5 times. Generative AI market growth, sharp rise since 2020. And, you know, I mean, it doesn't say why that is. I can tell you why that is, because AI before 2020 couldn't really do anything. You know, if you look at something like Replit, which will code a website or an app for you, and for anyone really, anyone that can just talk to it, yeah, it might have been around 5 years ago, but it can do a lot. Now it genuinely can. It's not flawless, but it's getting there. So we can see investments are going up, chip market going up almost as rapidly as the AI market size. Okay, and then I asked it, so this is the potential flaw in doing all your work on AI, is that it's not always good with its sources. So I asked it to include a link to the source, and this is where we start to unravel. So if I click on the source, it should open up a website. Yes, it's done that. It's taken me to Statista. And what I've got here is I have got the default landing page for Statista. And it's saying that, okay, it's saying that I need an account. And it seems to have landed me on a page that has to do with dwelling rooms per detached house in Japan. Okay, so, like, yeah. None of this is useful to me, so it seems that I can't get to the data. Is the data free? I don't know. I'd have to search Statista. Did Google... let's just go back to the correct one here. Does Google have access to Statista? So that's another interesting question there. Or has it hallucinated this? Did it pick this data from somewhere else? Now, you can use other tools for this. So let's just get rid of this and just pull up Gemini again. When you go deeper with this stuff, you get into paid tiers, but they always give you a few searches free. So if you go to Google 2.5 Pro, it will, or in fact, possibly if you click deep research, and you might want to do both, the deep research particularly will go onto the internet and search for the statistics for you, try to corroborate them from other sources, and then give you, hopefully, some actual data that you could corroborate. So in this instance, we don't have that. So, okay, so we've got Grand View Research, and again, it's a landing page. So did it manage to get that data using an API backend that Google is paying for? I don't know. We've got some report from PwC that's impossible to see. We've got Statista's. Is that a default? It's not even a default landing page. This is an actual page. So it has in fact hallucinated its sources. Whether or not it had them in the first place, well, I suspect it did. I suspect it has got this data from somewhere. And the problem is that we don't know. One of them is Stanford, and look, finally we're there. Finally, we actually have a usable report. Again, we'd have to read it to corroborate whether or not it's accurate. But there we go. So this is a really good representation of both the opportunities that AI give us, and it's pitched us headlong into the risks, where it appears extremely confident about what it's made here. I suspect it's probably relatively accurate, but if I want to present this in front of anybody, then I'm going to have to go away and do a whole load of work to check my sources and see if I can get more than one source. But having said all that, just look at this. It's a really, really good data representation of what's happening. Everything's on the up, as you would expect. AI is the big news. So let's just go on to the second one. Now, the same caveats apply here. We are asking it for data that is very well known and very publicly available. And so I suspect that it is relatively accurate, but we'd have to go off and check it. So again, I asked for Gemini to create a web page for me. That web page would look at using something like D3.js and the CSS framework. I just said, look, make it look really nice. And I want to be able to plot a number of things against each other for year-on-year values. And so this is what I did. I asked for something called the cost of AI compute. So basically for each, let's say you want to analyze a sentence. This is a sentence. How much would that cost to analyze? Obviously, it's going to get cheaper as things go along. Computers get faster and they get more power efficient. So just on those two metric alone, we know that it's going to get cheaper as time goes on. Okay, here it is. I've asked it to do the same thing. Can you make the line graph bold? If I click it, very nice. Okay, and this is from the year 1999 through to this year 2025. Complexity of AI models. So we know crudely what even if we're not scientists, we know crudely what a neuron is, and that many neurons connected together make a brain, and that the nature of the connections between neurons make the intelligence in the brain. And we also know approximately that we've copied this idea in software to make large language models. And we therefore can also relate to the fact that, for example, a smaller brain, like the brain of a bird, has less neurons in and less connections. And so therefore, the likelihood is it is going to be less clever than something with a bigger brain, like a human. So these are fairly crude metrics. They're open for discussion, I realize, but let's take them as is and just apply them to AI. And it does appear that when we create AI with more connections, the AI is able to do more and appears to the external observer at least to be more clever. So looking at the complexity of AI models, we are potentially looking at how useful they are or can be to us. Number of transistors in microchips, this is known as Moore's law. Everybody says Moore's law is going to run out. Yes, there are some real limitations in terms of physics as to how small we can make transistors. But nonetheless, we do seem to periodically get around these issues. So Moore, of course, was the CEO of Intel back in the 80s, I think it was, and he just made a rather crude observation that they were managing to double the number of transistors on a chip every year and a half. That was, give or take, relatively accurate. But then if you graph that, what you get is something called an exponential curve. And what that means for us is that at some point, the doubling of the speed of microchips is going to get so extreme that we will not really know what to do with them anymore. They'll be so insanely powerful that we can't invent things that will compute on them. I'm sure someone can disagree with that. Okay, and then performance per watt of microchips. So we know that, for example, a modern mobile phone vastly outperforms a desktop computer from the mid-80s, let's say. It's doing that using tiny amounts of electricity from a battery that lasts all day, compared to the 80s computer, which you had to plug into the wall, used mains, and it ran very hot. So there we go. Let's look at what else we've done here. So I've asked the I've asked the AI that made this to make a button such that I can switch from a linear scale to a log scale. So if we look at a graph like this and we plot something that doubles every X amount of time, if we change it to a log scale, it looks like a lovely straight line, and that's when we can see that something is genuinely doubling. It's a little harder to see on a linear scale because you kind of have to work out what's going on here. So this tells us that all of these metrics are doubling every X amount of time. And so I asked it to extrapolate the data to 2035. The reason I chose 2035 is that obviously it's only 10 years away, and that we can kind of imagine 10 years into the future. That's not hard for any of us to do. So there we go. Just 10 years into the future, the complexity of AI models has gone up to just kind of through the roof, really. Microchips have gone through the roof, and performance per watt has gone through the roof. And so what we're looking at there, very crudely, is probably extremely small microchips that are phenomenally powerful and that are using just incredibly small amounts of electricity. It could even be, and this is getting a bit theoretical, but it could even be that the amount of electricity they need to use is so small that batteries become obsolete. Indeed, they might be able to run off something like body heat. So again, just checking our log scale. Is this, yeah, all of these things continue to double. I mean, I guess we've asked it to extrapolate what was already a doubling frequency that didn't have any deviations. So yeah, it's going to stay the same. And then I asked AI to tell me what the estimate was for the complexity in billion parameters of a human brain. And it came up with an answer, and I asked it when that would be, and it said, I think it was 2084 or 2085. So then I asked it to extrapolate that graph and to place a dot on there when AI matches human brain in terms of simple billion parameters. Back to our log scale, of course, everything's going on there. Now, I thought this was interesting to show you because when you zoom out like this to this extent, you can really see the implications of doubling frequency in terms of our ability to predict what happens next. So I don't know if it doesn't mouse over and tell me exactly when this is, but let's assume this is 2085. The graph now is so steep that we could see that potentially in the year 2086, the doubling is happening, every less than 6 months. And so in 6 months, it's nearly twice as complex as a human. And 6 months after that, it's 3 times more complex than a human. And 6 months after that, it's 6 times more complex than a human. And by the time we get to 2 years after that point, we have a system that's so complex that it's potentially indistinguishable from God. And why I've shown you the graph is because it's inescapable to the best of our understanding. And finally, I'm just going to observe that there is a reason why this graph might be wrong, and it might be overly conservative. And that is that what we're not taking into account are things like our ability to compress these models. So compression is when you simply take a digital shortcut to reduce the amount of compute time or storage to do a certain thing. And I'll give you an example for that by just looking at, for example, this page here. If you were to take every single pixel, and there's 1,900 pixels wide and 1,080 pixels deep, and write down the color of each pixel, it would take a certain amount of time to do that, and space. But if you were to simply say, draw a box in the middle and color the box white, you've had the same effect as before, but you've done it in a very small amount of storage space. And you need a little bit of computational time to decode that and then to color the appropriate pixels. But you've still done that in a very, very small amount of time. So that's basically what compression is. There's quite a large number of reasons why this estimated human brain parameter and its connection to whether or not an AI will become an artificial general intelligence. Yeah, there's no kind of like correlation there. I think that it could happen a lot sooner. I mean, just logically, we consider a dog to be conscious and intelligent. Dogs are clearly have less parameters than human minds. But then we could say the same about a parrot, you know. So consciousness and computational complexity don't necessarily go hand in hand. And that takes us in a big circular argument to we don't actually know what it is that we're creating here. We don't know whether it'll wake up or when it'll wake up. And we don't know at what point we're going to stop understanding what it is that we've actually got. But in terms of our usefulness right now, look, taking data from the internet or from statistics and using a language model to talk into existence a lovely graph like this is a really incredibly simple task. All you have to do is talk as if you would talk to a child, really. Use small steps, ask it to do small things, gradually work up into something bigger.